Good afternoon, everyone. It's quite interesting to see the presentation earlier about the business case of the port, and I will be talking about the real case of deployment of the Shanghai port, which we have deployed earlier this year through a third-party company. First of all, my name is Tatesh. I work for Huawei in the wireless division, and I support the enterprise division, who's basically doing this product. And I represent Huawei in the board of directors of the MulteFire. So I will be talking about the requirements from the port authorities, what they need to do for the automation, and then I'll explain the product that we have deployed and the type of automation that we are targeting in the first phase, and then the upcoming phases after that. So first of all, it's very obvious that the ports are exploding, and if we see the number of containers that are being handled in some of these big ports, like Shanghai ports, a quite high number of containers. Shanghai ports in 2015 handled 40 million containers, and every year they increase between 3% and 4%. So we expect that this year they will be able to handle 50 million containers. So you need really mechanism to try to automate the ports in order to get operating status data to the control units and to be able to do maintenance and preventive measures to have an efficient port operation. So a little bit of background about the Shanghai port. It's phase 4 now in the expansion. It has 26 key cranes. And it has, I don't know if it is bigger than the Singapore port, but I'm told that it's one of the biggest in the world. And it supports 130 vehicles of Agv vehicles. So this is a background about it, and Let's talk about the requirements, what we need to do. So there are three areas of automation that can happen in a port. First of all, the area of automating the Agv, or controlling the Agv. Second, supporting CCTV, or basically video surveillance of the cranes. And then the remote crane monitoring system, 3 areas. And at the moment, we focus only on the first area, which is the Agv control. And what you want, ideally, is to be able to get data from the guided vehicle in the uplink to report the positioning of it, to report the speed. And they work on the hydraulics, so they report also the pressure of the Agv and the battery data. On a downlink, also similar level of tuning instruction and transmission data. In our deployment, we started with the first phase. So the next phases will involve the other use cases. But I will be touching base on those use cases as well. So the challenges in a typical automation of a port deployment, as we mentioned earlier in the presentation, basically to be able to avoid the blind spots and to have a wide coverage, because basically you want to reduce the number of sites and make it simplified as much as possible. You want to have shorter latency, and you want to have the latency consistent across, even when you have a high number of Agvs. As we deploy multiple base stations or multiple access points, and the Agvs could move actually from one cell to the other. We don't want interruption when there is handover. So mobility and basically service interruption has to be minimized. Interference, especially when AGVs are next to each other, need to be immune to interference, and basically maintenance. We need to reduce the cost and basically reduce the number of APs in order to reduce the maintenance. So these are basically some kind of illustration of the measures that the measurements that these third-party companies have taken. Originally in the port, there was a Wi-Fi network deployed, and they did the testing on the Huawei product, which is based on eLTE, and basically measured through these requirements. So in terms of coverage, we can merge, it's a scale measure between 0 to 5. We can say that, we have much higher coverage or better coverage. We have a very simple architecture that we can deploy, and light and small equipments, and we can say that we reduce the number of sites by a significant number. We support multi-user latency, which means that at the highest number of AGVs, when they're all working, we can maintain a consistent latency, which I have figures that I can show later. Mobility is very important, because the MulteFire system is based on LTE. We also use the handover from LTE, and that is very well known as a system that supports seamless mobility. And then we support industry-grade reliability. Now, in addition to this is comparison with Wi-Fi. We can also say that we have an LTE-based security system that we inherit from LTE. And we have a future-proof. So, we have MulteFire 1.0, we have MulteFire 1.1. We're planning for MulteFire 1.2. And these all have, enhancement of features that are coming to support the requirements of different enterprise customers. We're also going into the 5G domain shortly in the MulteFire Alliance. Okay. So now let me talk a little bit about the product. So the product that we have deployed is eLTE. eLTE is a Huawei trademark, which stands for Enterprise LTE. It's a product that we have that we deploy for our enterprise, and it supports basically licensed and unlicensed spectrum. It supports all the features that are available in LTE, but in addition, it supports MulteFire. And it is a very simple product that supports very simple architecture and very easy to deploy. And we have also the private core, which is also part of the product that we support. So in terms of the latency, we can support in measurement, real-time measurements, that's been done by a third-party company, 60 AGVs with a latency below 30 milliseconds. And end-to-end latency, I think we can probably get less than 100 milliseconds. For the coverage, we have 2 to 3 times the coverage of Wi-Fi that was deployed. I have also some figures about reliability. I can show that. We have 0 packet loss compared to, for example, 0.5% packet loss in our test. And for the handover, we have less than 50 millisecond interruption time. Okay, so this is just an illustration to say that, the key thing is that when you have congestion, when you have more number of devices, then the system has to sustain the throughput, and it has to also sustain the latency. That is the key requirement. And you want to avoid any unplanned shutdown. Now, in terms of why the coverage is wide, we implement some techniques. This is just to answer your questions. It's basically implementing inherently in the standards, in the MulteFire standards, some time diversity using TTI bundling. And we also have multi-user MIMO support, which allow us to have a better link budget to have better coverage than Wi-Fi. Now, when you have that, this is a key feature, you basically reduce the number of sites. And in the port itself, it costs them $1.5 million per site. So if you're able to reduce by half or 3/4, then you're making a lot of saving there. Now, we also deploy, obviously, interference mitigation, which is inherent in the LTE system. We support redundancy in this system, so we have multiple links. So if one link fails, then it will continue to operate. And inherently, because we have the LTE quality of service guarantee, we also have those QoS levels where we can prioritize traffic operation. So that allows us for a higher reliability system. The mobility, what we tested with very high-speed Agv, and as I mentioned, we can achieve the handover without interruption with 50 milliseconds, or less than 50 milliseconds from one cell to the other. So this is basically a summary that we have a very simplified architecture. We have a very simple architecture. Some figures are missing, but we are able to go into a very complex port there and can basically replace a system or deploy a system there and support the use cases. In this example, where we have the Agv dispatching platform, and we have the access points and the CPEs on the Agv. And what did we achieve with that? We were able to reduce the manpower by 4-to-1, basically. And the port efficiency has improved from the ability to handle 28 containers to 40 containers per hour. That's even from phase 1. So I think we are looking for further improvement and enhancement. So that is a real case for the Shanghai port. I just want to touch on other things that we are engaged with in terms of some other use cases that support eLTE and the deployment of MulteFire. So 3 use cases here. We are actively working with our customers, one on the metro, on the rail, and second on the manufacturing, supporting goods tracking, Agv control, and robotic monitoring, and industrial park, especially in the gas and oil field. So just very briefly, we're working with BYD, Skyrail. It's a very important company in China, and we have been doing some trials on basically supporting eLTE or MulteFire on the Skyrail to basically support the train control and passenger information system and the closed circuit television. And that, it's not in deployment yet, but the trial is very promising, and we expect that this is the direction that it will go as well. For Digital Factory, we have been working with a number of factories, in fact, on trials in China and in Europe. As mentioned earlier, Narrowband IoT is being finalized in the standards in MulteFire 1.1. But we are testing narrowband IoT there. We are able to do robot control by implementing those sensors, and we can do property management. So the key thing is that at the end we will achieve production efficiency and reducing production cost and enhancing management efficiency. For the industrial park, which is also a very exciting field for us, and we have been talking to many customers, we think that the MulteFire is very well suited to enhance for these particular use cases where you can do mentioning many of the use cases like gas detection, fixed monitoring, video monitoring, mobile inspection, and supervisory tool. It's still in early stages for the MulteFire deployments, but we are really very excited about it, and we think that it will actually be the cornerstone for the future automation revolution that is that's happening. Now, we're missing some figures there, but this is just to illustrate Huawei's commitment to the MulteFire standards. We are committed to it, and we are basically spending out of our enterprise revenue. We spend 10% of our income on the R&D related to this kind of product, and we have about 500 employees working to support the enterprise product. Okay.
Your trial that you've just done, is that to MulteFire 1.0? You've been able to meet those standards?
It's for MulteFire before the 1.0 was officially released, but it is almost MulteFire 1.0.
Any other questions?
Just quickly, do you see MulteFire as or eventually becoming an access technology, or do you primarily see it as sort of a secondary network, either industrial applications or effectively a better, more secure Wi-Fi?
So from Huawei's point of view, we are focusing on enterprise use cases, private networks, but in the future, it could become, access technology. This is probably not a use case that will happen immediately. It may happen in the future because obviously there are many things that, we are in, although we've been 3 years in this standardization, but we still don't have a commercial chipset as ready yet. We we build our own chipset, but once we have all that in place, of course, it could potentially become similar to Wi-Fi.